Hello everybody out there in YouTube land. This is Good Times for All, or Zachary Zabala here if you prefer. In this video, we're going to be looking at how the electric field differs when dealing with something that is an open sphere and something that is somewhat of a closed sphere. And we're going to see how a negative field will be created inside of this one, and everything will stay within it. And to where this one, which is half open, the top is the widest part. Some of the paper may stay inside, but you will definitely see some of it fly out. And in this one, it should not. Everything, you might see it lift up a little bit, but it'll get sucked right back down in. All I have here is a mason jar lid, a ball canning jar that I set on top of this to allow me to set things on top of the dimple, which resides on top. And the first one we're going to do, I guess we'll do this one first. Well, no, we'll do this one. It doesn't really matter. I'm not going to use all the paper. I'll just put a little bit in there. And all it is little pieces of tissue paper that are torn up. So, I'm not even going to put that many in there. We'll just put that many in there. Well, we got them, so we might as well use them, right? Okay. So we have our paper in there. When I start charging this, it will run through the lid into the glass bowl. It will start positively charging the glass bowl, and eventually it should positively charge the pieces of paper, which will then fly out of the glass bowl. So I'm going to start cranking it. We got one crank, two. At two cranks, it already started flying out, and looks like a few did stick to the bottom. It just happens that way. Oh, they're wanting, and there they go, right onto my face. Woo! Did you see that? Flying back and forth from my nose. Wow, I can feel that on my nose. Wow, I better back up a little bit. I can feel that piece of paper when it was pop, 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 pop. I had one stuck to my... Wow, that was pretty cool. Oh, this is fun. I love this stuff, folks. I forget what that's called. What that happened to Walter Lewin. He does it with a balloon. We'll be doing that one later. Okay, now I'm going to take the same pieces. I'm going to ground them all. Make sure they lose all that charge that they had on them. Actually, I'm going to get some more. These are all sticking together. Nothing different, just pieces of tissue paper. I'm going to drop those back in there. As you can see, just tissue paper torn up. And we're going to put them inside the jar. You can see they're nice and loose in there, moving around. Set that on top. Make sure the negative isn't sitting in my lap again. And here we go. One crank, two crank, three crank, 4, 5, 6, 7. These barely moved at all. The first time I did it, they actually started flying up to the rim and then went back down. But as you can see, none of the paper on the inside is getting a positive charge. It's moving around a little bit because there is a little bit of a positive charge in there because the hole is open. Now, if it was totally closed off and spherical, there would be no charge on the inside. But as it is, there's an open hole. There will be a charge in there. But as you can see, all the paper stayed on the inside. So all that negative charge gets built up on the inside, and all the positive stays on the outside. So somewhere in there it's zero. We'll get into that, all that kind of stuff. You see how much that moves? I don't know if this thing is... That's all solid. Oh. There we go. That thing was a little bit loose. It was unscrewed a little bit. There we go. That'll be... I doubt it had anything to do with any of the conditions we were getting. It was just wobbling around while I was... So we're going to do it one more time here. And 1, 2, oh, it's lifting. Oh, some came out. And then as you can see though, the rest are stuck in there. So one must have got to that magical point where it got to the positive and got a positive charge on it. The negative, you can see it's being pulled down almost because it's negative. And the glass jar is a positive, so they're attracting to each other. So every time I'm cranking it, it's just pop, 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 pulling the negative charged paper down to it. Oh, it almost started lifting there, but nope. We'll go back one more time to the jar. See if I can't make a mess here for you. Actually, we've seen the glass jar. Now we're going to go with plastic to show how once a charge gets big enough and strong enough, it will jump through the plastic, which is an insulator, not a conductor. It will still conduct electricity to the paper, which will then fly out. And it didn't take very long. A couple cranks. So even when something is, whoa. Now see, I can grab that and I didn't get shocked at all. Because it doesn't hold any of the electric charge. The electric charge goes through to, and see, there you go, into the paper and out. But this thing wasn't, it's a negative. It tries to remain itself neutral as much as possible. But as you can see, a lot of the paper wasn't positively charged enough yet. It almost appeared as if it was right in the middle. Wow, that's pretty cool. And around the ring where it was touching it, it actually stayed negatively charged. Huh. Pretty neat stuff. And this stuff is still really charged. It's all clumping together. Wow. So that's it, folks. Probably already longer than I wanted to make it, but just showing how the shape affects what happens with the charge and what happens to things within and how all this stuff works. Still a lot more experimenting to do, but that was something interesting I just learned and I wanted to share with you. So that's it. This is Good Times for All signing out, and as always,